Hey everyone, Chang here and welcome to my channel. Today we're going to talk about the unrefutable, the unquestionable, the most sacred, holiest of holy, the 7 rules of algebra. Just a side note, some textbooks claim there are 9 rules instead of 7. The reason for that is because for rule number 5 and rule number 6 in this video, they decide to separate it into 2 versions, an addition version and a multiplication version. Yes, today we are going to be talking about the 7 rules of algebra. It is actually pretty interesting when you think about it. All of your hellish anguish, no, go away, and all of your heavenly pleasure, oh yes, please, more, regarding algebra is based on these 7 rules. While going over each of these rules, I'm going to break into 3 components. The first one is the more formal definition. The wording is going to be very similar to some of the textbooks out there, right? The second one is the rules itself in more layman's term. So basically what it really means. And the third one is the actual name of the rule. So for your reference, if you want to look it up further, you know the name of it. Rule 1. For every number, there exists another number such that when you add them together, you get the original number. That just basically means that the number 0 exists. Think of it this way. 0, when you add it to any number, no matter what it is, it's still going to end up being the original number. So this first rule here is known as the additive identity. You can sort of guess why it's called the additive identity, right? You're dealing with addition, identity. In this case, it's sort of a stretch, but it's noting that the most smallest, the most basic of component in relation to addition, and what smaller is there than 0 itself. Rule 2. For every number, there exists an equal and opposite number such that when you add them together, you get the additive identity. Now remember, the additive identity is just basically the number 0. So what this rule is basically saying is that for every number, there's an equal and opposite number such that when you add them together, you get 0. This second rule is known as the additive inverse. Basically what it does is that it brings the concept of negative numbers and indirectly subtraction into algebra. Rule 3. For every number, there exists a number such that when you multiply them together, you get the original number. Now, based on your experience with the first rule, you can sort of guess what this rule is talking about. It's talking about a number such that when you multiply it with the original number, you get the exact same number. Well, in terms of multiplication, the only number that this could be talking about is 1. So this third rule is basically known as the multiplicative identity. So from your experience in the first rule, you can sort of see that this is basically the multiplication version of the first rule. Rule 4. For every non-zero number, there exists another number such that when you multiply it with the original number, you get the multiplicative identity. So remember, from our previous rule, the multiplicative identity is just 1. So what this rule is saying is for every number that is not 0, there's the key, not 0, there exists another number such that when you multiply them together, you get the answer 1. The name of this rule is, well, you guessed it, the multiplicative inverse. And this is also where division comes into algebra. Rule 5. Solutions to addition and multiplication exclusively does not change regardless of how the numbers are grouped. Now, this rule sounds actually more complicated than it really is. I think going through examples would explain this rule a lot better than just trying to talk it out. So here's some examples. Let's say you're trying to add these 3 numbers, 1 plus 2 plus 3. Now what this rule is saying is that it doesn't matter what you add first. So you can add the 1 and 2 first and then 3, which will give you the answer 6. Or you can actually add the 2 and 3 first, then add 1, and the answer is still the same. For multiplication, let's say you want to multiply these 3 numbers. 2 times 3 times 4. The same rule applies. Let's say we multiply 2 and 3, we would get 6. Multiply it by 4 afterwards, you get 24. Now, if you change the order and you decide to multiply 3 and 4 first, which gives you 12, then you multiply 2 times 12, you still get 24. So the answers are still the same. Now, this rule is known as the associative property. Now, as I mentioned in the beginning of the video, some textbook actually breaks it into two versions. You have the associative property of addition and the associative property of multiplication. As you guys can sort of see, this is one and the same. Now, note here, a key thing I want you guys to remember in this situation is that we only focused on addition and multiplication. This rule actually does not apply for subtraction and division. Rule 6. The solution to addition and multiplication exclusively does not change regardless of the different order you combine the numbers. Now, this rule is actually slightly different from our previous rule, even though they sound very similar. This rule is actually saying that no matter the order, so if you have a group of numbers that you're trying to add together, you can switch all the orders around and the solution will still be the same. The same can be said for multiplication. If you have a group of multiplication and you switch all the orders around, the answer will still be the same. That's the power of this rule. So for example, let's look at the simple problem, 7 plus 8. The answer is 15. That part is simple. What this rule is saying is that rather than just adding it through 7 plus 8, I can flip it around and do 8 plus 7. The answer should still be the same, which in this case it is. 8 plus 7 is 15. Now, there is a multiplication version of this rule. Let's say we are working with this problem, 8 times 9. The answer is 72. What this rule is saying, as you can guess, is that if I flip it over, 9 times 8 instead of 8 times 9, the answer should still be the same, which in this case, it's 72. Now, this rule is known as the commutative property. Similar to Rule 5, certain textbooks actually want to separate this into two versions. You have the commutative property of addition and the commutative property of multiplication. Now, once again, this rule actually does not work with subtraction or division. Rule 7. This is known as the distributive property. Now, there's a more formal definition for this rule, but it involves writing a lot of variables, which I don't want to be the focus of this video. So basically what distributive property does is it allows you to combine multiplication and addition. But what do you mean? So notice for Rule 1 all the way to Rule 6, each and every one of those rules applies separately. It either applies completely to only addition or it applies completely to only multiplication. This rule actually combines the two. It allows you to intermingle multiplication and addition together. So all those times where you're working with different operations, you have addition and multiplication all in the same problem, it's because of this specific rule. So for this rule, I think it's a lot easier if I show you guys what it means through an example. So we have 2 times parentheses, 1 plus 3. Now, some of you guys are going to breeze through this. You guys can see that 1 plus 3 equals 4, so 2 times 4 must be 8. And there's nothing wrong with that. You guys are absolutely correct. Now, what this rule is saying is that there's another way to approach these kind of problems. Now, once again, we're going to go back to 2 times parentheses, 1 plus 3. But rather than combine the 1 plus 3, because in other problems, there might be situations where you actually can't combine them just yet. You can actually distribute, get it? The name, distribute 2 into every single component inside the parentheses. In this case, there is a 1 and a 3. So you have 2 times, and you distribute it to 1, so it's 2 times 1 plus 2 times, and you distribute it to 3, so it's going to be 2 times 3. So this is what you have. You have parentheses 2 times 1 plus parentheses 2 times 3. Now 2 times 1 you know is 2, and you know that 2 times 3 is 6. So you have in the end 2 plus 6, which still gives you 8. So basically that's what this rule does. See, that was pretty simple, pretty straightforward, not too bad. Not too complicated, right? Well, let's try practicing with these 3 problems.
1.
Just a keynote, I will have the answers in the description for those of you guys who are curious and want to check your answers.
3.
Thank you for sticking with me until the end of this video. So let's summarize basically what we went over. Now, these 7 rules are basically the foundation of algebra. Everything else is actually derived or built from these 7 rules. Rule 1, known as the additive identity, basically says that there exists the number 0. Rule 2, which is known as the additive inverse, gives us negative numbers, or more importantly, it gives us the whole concept of subtraction. Rule 3 is known as the multiplicative identity, which basically gives us the number 1. Rule 4 is known as the multiplicative inverse, which gives us the whole concept of fraction, which indirectly actually gives us division. Rule 5 and 6 is known as the associative property and the commutative property. Now, the real power in these 2 rules is when you combine them. What it does is it allows you to switch the orders around, group the numbers in whichever way you want, as long as you're working with all addition or all multiplication. Rule 7 is known as the distributive property. Now, this is the cherry on top. This is the best rule out there. This is what allows us to intermingle addition and multiplication together. So prior to Rule 7, we couldn't mix the 2. Now with the distributive property, we can actually work with multiplication and addition in a single problem, and that is amazing. Now lastly, please like, comment, and subscribe to pledge your loyalty to the almighty rules of algebra. I will try to post at least 1 video every week. Now, are you a believer or a heretic?